Okay, everyone, welcome to the next video. In this one, we're going to be doing, actually, I said two, we're actually going to be doing three. We're going to be doing three more examples of integration by parts. The first one's going to be a pretty straightforward application, which I have right here. The next one will be a little bit trickier integration by parts problem. And the final one is a case when to solve an integral, we actually have to do integration by parts twice. So we'll see how those manifest themselves. But for right now, just give this integral right here a shot. Remember, with integration by parts problems, these can take a very long time to do. So really try to do this one on your own and keep working at it. It might take you 10 minutes, 15 minutes to evaluate this integral. Don't worry about that. It's more important that you try to do this on your own than just watch the video all the way through and never try it with yourself, just passively learning everything. If you're passively learning, you're never going to learn how to do this stuff. So pause the video, try to solve this integral on your own. Okay, so if you gave it a shot, again, there are lots of different u and dv combinations we can choose, but the correct one to do in this case would be if we said u is equal to x, therefore dv would be equal to cosine x dx. Okay, so if we differentiate u, we get du equals dx. That's nice and simple. And if we integrate cosine x, we get that v is equal to sine of x, because sine is the integral of cosine. So if we plug this into our formula up here, we'll get this integral is going to be equal to u times v, which will be x sine x minus the integral of v du. V is sine of x, and du is just dx. And again, looking at this integral, that's way simpler than the integral, way more simple. Okay, yeah, way more simple. Not English class. Get off my back, people. All right. Anyway, it's way more simple to do this integral than it is the original one we had. So we're on the right track, okay? So if we continue to fill this out, we're just going to get this is equal to x sine x. And then the antiderivative of sine is negative cosine. So then this will just be plus cosine of x. And then we add our plus c right here to the end, okay? So that's the answer to that one. So between this example and the one that you saw in the previous video, this should be, for the most part, enough to get you through the vast majority of integration by parts multiple choice problems you could see on an AP exam. But I'm going to give you just a couple more examples because you can always get those tricky ones in here. And anyway, it's just cool. You know, it's a really cool formula to evaluate some pretty complicated integrals. So we're going to continue on and do another one. Now this one is going to be a little bit different, okay? This one, it actually, when you pick the u and the dv, you'll see that it's probably a little bit easier than you were thinking of making it. But pause the video, try to evaluate this integral. Remember that we don't know what the integral of natural log of x is. The integral of 1 over x is natural log of x, but we've never talked about what this integral is. And obviously, when you see this integral, there's no u substitution we can make to make this thing prettier or to substitute the variable u in anywhere. So we got to try to do integration by parts. So pause the video, try to do this one. All right, if you tried this one, here's the trick here. If we say u is equal to natural log of x, that means dv is equal to dx. Therefore, u, the derivative of natural log, will be 1 over x dx. And then the antiderivative of dx, well, that's just going to be x. So v is just going to be x. So if we rewrite this integral, u times v will be natural log of x and multiplied by x. You know, there we go. And then minus the integral of v du. V is x, and du is 1 over x dx. So wow, that becomes a really simple integral to solve. These just cancel, and we're just left with 1. So the final answer is natural log of x times x minus x plus c. Okay, so this is a example of a type of problem that you wouldn't remember. I told you oftentimes when you're doing integration by parts problems, you're looking for some function multiplied by another function where you don't have that derivative or that function then similar to derivative relationship that you're looking for with u substitution. But in this case, as you can see, remember I said any integral, it doesn't matter what it is, can be put in this form. This is kind of an example of sometimes a really neat trick to do in integration by parts is simply just to say dv is dx and u is whatever else is inside the integral. And when you actually run through the integration by parts sequence of events, it ends up giving you an integral that's pretty easy to solve. Okay, so again, this is kind of this would be a low blow if you would get an integral like this on an AP exam. But there are other integrals where we do integration by parts twice. And so I will show you an example of that. Now, I wouldn't put too much effort into memorizing integration by parts twice, because truthfully, actually no, I think I have seen it on a couple of AP multiple choice problems. So I take that back. So there's a good chance you might see integration by parts twice somewhere on there. So this is an example of that. Don't try to do this one on your own, because you could get really confused really fast. But I'll show you how in some cases like this, you'll do integration by parts once, and you end up with an integral, or this integral, which is more simple. I got it right that time. More simple than the original integral you started with, but it's still one that you just can't solve. And so you actually have to use integration by parts again to figure out what that integral is. Okay? So an example of this is this one. And like I said, I'm just going to work through this one. Just try to follow along. If we say u is equal to x squared and dv is equal to cosine x dx, this means that du is 2x dx and v is going to be sine of x. All right? So if we plug this into the integration by parts formula, we're going to get u times v will be x squared sine of x minus the integral v times du is going to be sine of x times 2x dx. And as you see right here, we can't use u substitution on this because we don't have that function similar to derivative relationship that we're looking for. But we do have one thing multiplied by another thing. So what I want us to do right here is actually do integration by parts again, but we're going to do integration by parts to this integral right here, okay? So for that integral, we will say, in this case, that u is 2x, dv is sine of x dx, therefore du is 2dx, and v is going to be negative cosine of x. So if we plug that into this formula here, remember, we are only solving for this integral right here. When we solve that integral, we got to remember to add this little guy on the other side, because the x squared sine of x was fine. We have no problems with that. That's all hunky-dory, as they say. Okay? So anyway, when we have this, if we do integration by parts on this, now we'll have u times v will be 2x times negative cosine x. And then we will have minus now the integral of v du, so minus the integral of negative cosine x times 2 dx. And so now we see, finally we got an integral that we can solve. Okay, this one works out. This one's nice. All right, so if we go ahead and solve all this stuff, we'll end up getting, this will be negative 2x cosine x. Then we will end up having plus 2 sine of x plus c. Now again, that's the solution just to this integral right here. So if we want the entire solution, we got to add this x squared sine of x. So it'll be x squared sine of x minus 2x cosine x, I'm running out of room here, plus 2 sine of x plus c. Whew, all right, that's a big one. All right, so remember, if we take the derivative of this, we'll end up getting just what the regular function was to begin with. But yeah, for the most part, we're going to be, we forgot one thing. What did we forget? We forgot that we had a minus sign right here. I'm sorry about that. I completely forgot that. So that means this will end up being x squared plus 2x cosine of x and minus 2 sine of x. Okay, I apologize for that. I completely omitted that. Yeah, so you know, keeping track of minus signs is nothing trivial. It's nothing trivial. It's actually very easy to do. And I actually think I was going to say something else in this video on one of the things up here. I think it was, here we go, yeah. And okay, I'm sure some of you were saying, yeah, I realize I did the wrong word here. I should have had another O in there. So yeah, old Dr. Freckles made another grammar mistake. Okay, I wanted to point that out. So anyway, I recognized it, but again, this is a screenshot, and I'm not going to change that. So there we go. To make everyone happy, let's put another O up there. Okay. So this is all we're going to have on the videos for integration by parts. So come to class ready with questions. And the next video, we'll deal with another method of integration, which is called partial fractions.